Okay, so here we will solve homogeneous equations with constant coefficients. So we will solve ODEs of nth order. So an, yn, n minus 1, n minus 1 derivative, a1 first derivative, so prime, and then a0 1. And ai are constants, real constants. Okay. So we make the guess. Also called time size, y equal e to the rt for r in the complex numbers. Okay. So that means you plug it in. Okay. And a1, and then ert. Okay, so if you take the derivative, you get r to the n. R to the n minus 1. And a0 rt. Factor out the exponential. And you got a nth degree polynomial. Okay, so by the fundamental theorem of algebra, we have n solutions, n roots, R1 to Rn. Okay. Now we have to split cases. Case 1, if they're all distinct, then the general solution is y general is equal to C1 e to the R1, and then Cn e to the Rn t. We will mostly work with n equal 2. So let me give you the solutions. So we have equation y double prime, by prime, cy 0. And for y equal to e to the rt, you get ar squared, br, and c. Okay, which is a quadratic. So the solution is minus b plus minus b squared minus 4ac. Okay, and so the solution would be c1. Let me write it, plus minus e to the r minus t, and then c2 e to the r plus t. Okay, so these are the two solutions to our ODE. Okay. Case 2. We will do this only for n equal to repeated roots. So for n equal to, suppose R1 is equal to R2. Then we don't have independent solutions. So check. I can do it now. So we have one solution, e to the R1 t, and Y2 is the same guy. So not independent. Okay. So we need to devise a second solution. All right. Okay. So recall in reduction of order, we had the standard form equation. So we have an equation with y1 equal to some function, then y2 was defined to be y1 times some other function, right? So it was an integral y1s squared, and then the exponential of the second coefficient, it's b over a. Okay, so y1t, this is e to the r t, and this is e to the minus, s, 0s, and then b over a. Okay, so let's say what do we have? y1t minus 2rs, and then this guy, it's minus ba times s. Okay, now recall the formula. So this is the formula. Okay. So in the case of repeated root, R1 is equal to R2 is equal to minus B over 2A. Okay? And so 2R is equal to minus B over A. So these guys cancel out. So minus S or plus B over A. This guy is 0. Okay. Let me make it clear here. So it's plus and it's 0. All right. So this is e to the r t and then 0 t1 ts, which is e to the r t t. Okay. So the general solution would be c1y1, c2y2, c1 e to the rt plus c2 e to the rt times t. Okay. So yeah, that's those are the two cases. If it's repeated, you have to add an extra t, and if it's not, where is it? If it's not, you just keep the two roots. Okay. So next we'll do some examples.